Okay, so we are going to be going through here the calculations, all questions pack. Now this is something which we find will link to 2.1 and 2.2 and also for some revision for you year 11s. Okay, and we're working towards now, this booklet really looks at moles, reacting masses, and it also brings in some of your calculating MR and percentage composition now. Just so you've already got the YouTube code, you know where you are. Now these are all higher tier topics. I just want to stress that. Higher tier calculations. So we're going to first look at question number 1. So I'm going to just zoom into there for you. Okay. So today, first one is just a data task. Okay, so we're just looking at describe how the information in the table shows that silicon is difficult to classify. Now if we wanted to look, I know aluminium and phosphorus are both, one is a metal and one's a non-metal. So we're looking at how silicon compares to either way. So I've linked properties similar to metals and I've looked upwards and downwards for non-metal respectively. Okay. Question number 2. This links to your knowledge of group 2 and period 3. Now I would have just looked at my periodic table here. And we just need to remember that groups go downwards and periods sideways. Okay. We then got the chemical formula as CuNO3O2, give the number of nitrogen atoms. Now all I've done there, what you need to be careful is that it's in the bracket, and because that 2 is there, it's going to times everything in there by 2. Okay. Now, give the chemical formula of silver oxide. I just put Ag. I know we don't actually need to know this for year 10, so I wouldn't stress yourself for that one. Now I'm going to zoom back out now, and we're going to go on to question 2. Okay. So we'll start on the left first. So we've got a reacting mass question in this. Now there are quite a few of these, so I'm really going to focus on modelling this one for you. And then the last ones, really, they can be used as examples to look back to. Okay, and I'll highlight that. Okay, so first of all, it's reacting masses. And just like we did when we learnt this first time round, I've thought, well, let's look at the key information in the question first. So use the above equation to calculate the mass of copper produced on reacting 20.5 tons of copper sulfide with an excess of oxygen. So I've highlighted my copper sulfide and I've highlighted my copper. So I'm looking at both of these here and I know that. Now we're going to be using this equation, okay? Known mass over known MR equals unknown mass over unknown MR. But the first thing we need to do is calculate the MR. So you can see from down here, I'm using that table that we worked so hard to master, and I've got that there. Okay, and then just going to start filling this. So I've got 160, 128 respectively, and then I know my mass of Cu2S is 20.5, and I got that from the question, which means that my question mark mass is for copper. I'm going to use this equation here. I rearrange it, so I move my unknown MR up to there, which then gives me these 2, which finally leaves me, and I'm just plugging the numbers in, and you can see I made a bit of a mistake. We all make them. Plug in my numbers in, so I've got 20.5 over 160 times 128. So you're just going to look at that and see it both ways. And then finally then, it gave me an answer of 16.4. Now we're then going to use this answer again, okay, in here. Now, when the extraction was carried out with 20.5 tons, only 12.3 were made. Calculate the impurity. Now, this is percentage yield again. We're looking, as I've written here, for a percentage. Now, we should make 16.4, as we calculated, but we actually only made 12.3. So, we're going to do what we made over what we should have made times 100, which gives me a nice round percentage of 75. So that's our reacting masses question there. There's quite a few of them throughout. Now I'm going to move over now. This one here. Now we don't need to do 1A, that's a triple question. So if you're doing triple science, you'll be focusing that in another booklet. So we're going to just do MR here, and we've got element, how many, mass, and total. I don't think we need to go through that much. We're all very aware of how to do that, and we're fine to not do question C. So just be on this page. So just as usual, if you want to pause them as you go along. Now, similar data task here. So look and give the letter of A and E that is a liquid at 20 degrees. So what that means is that the boiling point is higher than 20. If you think the boiling point of water is 100, so at anything less than 100 is going to be a liquid, and the freezing point is 0 degrees. So we know in that gap between melting and boiling is a liquid. So we've chosen B because, as we can see from my highlighting, its melting point is minus 39. So we know it's going to be a liquid above that. But then its boiling point is until 357, so it's a long time until it turns to a gas. Now if I were then looking over here, we've got another reactive mass question. You can see throughout this that I have year marked them. So I'm going to go through this once more. Okay, and it's the same thing. If we look, we're doing reactive mass and then percentage composition. So I'm going to look at this part here. So we got, first thing I need to do as usual is I need to read the question and highlight my key information. Okay, so I've got mass of sodium carbonate that can be reduced from 126 grams of sodium hydrogen carbonate. Sodium carbonate here, I know it's sodium carbonate because I've got the CO3. And then I know this is the hydrogen carbonate, so I can tell the difference because this has got hydrogen in, this hasn't. Okay. Now again, I've highlighted my mass, which is 126 grams. And we are going to be using this equation, known mass over known MR equals unknown mass over unknown MR. And I've done a nice table again, so we've got mass, MR. But we need to find these numbers using the table. And I'm not going to talk you through that, but that's where I've done the table. And the nice squiggly line I've put, that means on the top I'm doing the hydrogen carbonate, and on the bottom I'm just doing the carbonate. So I've come up with my answers of 168 and 106. And I didn't need the periodic table, just because I've got that there, this information for me. Now I'm then going to just start thinking about what I have and haven't got. So my question mark is going to be sodium carbonate. And again, just going to plug those answers in. I'm going to move my UMR over by timesing it, so which then gives me 126 over 168 times 106 and 79.5. Okay, we're then going to have to use this question again. So it was found that the actual mass was only 70. Calculate the percentage yield, and I'm doing that to 2 decimal places, and I've again done actual over theory. So pause it if you need to have a little break on that question to really focus on what I'm doing. Okay. Now we've got another reacting masses question. Just pause it here because there's no need for me to go through that again. Just look at those, try and do them yourself. Okay, and it's the same process. Now finally, why was the yield less than 100? Now there's a lot of reasons we could have thought about that. We could have had product lost or the reaction incomplete. And then finally, why was it carried out under dry conditions? Well, I want you to think about when we had... I want you to think about when we looked at those reactions of the group 1 and we were dropping the lithium and sodium in water. So if there's water, because it's not dry, they will react very violently. Okay? Now, this is a good question here. Okay? Now, all this question is, it looks very complicated, but it is a case of using the equation they've given here and the information. Now this is something I really want to earmark for you. Now abundance is that there, so it's the percentage present in the sample, okay? And our isotope mass is this number. So trying to trick you out. Now lithium 6, its mass is 6, and lithium 7, its mass is 7, okay? Now all I've done is I'm then going to put my answers, my information I've got, so I'm going to do 6 times 7.59, 7 times 92.41, and I'm going to divide that 100, and I've got that equation all from here, and it's going to give me a 6.924, and I've given it to 3 decimal points here, and I've made a mistake, haven't I? 3 significant figures. See, we all make them, so I'm going to cross out that 4, so it's going to be 6.92, so I rushed a little bit there. Now, state the difference. Well, they're isotopes of each other. We know that an isotope is same number of protons, different number of neutrons. So lithium-7 has one more neutron than lithium-6. And that definition straight off our knowledge organizer. Now we've got another data task here. So we're just looking at this information and interpreting it. This question is fairly simple. We're just looking at the melting points and seeing that obviously it increases because we're going from a minus 219 to 450. And then, a bit like our question about looking for the one which is a liquid, we have to think about what selenium is at 400 degrees. So I know at a melt above 221 it's a liquid, and below 685 is a liquid. 400's in the middle, so it's a liquid. Then now we've got a nice MR question. I don't think we need to go through this. Just want to focus on this view though. Calculate the percentage by mass. That's our percentage composition. So I've got my 79 and my 173 from that table. Okay? I just wanted to give SE is selenium. So that's where I've got the 79 from. Now we've got a nice moles question here, just towards the back end of the paper. If we look in here, it's 3 marks. Okay, 3 marks is all a process. Now we're going to be using this equation, N equals M over MR. Now I know I need to find the MR. They're not going to give me the MR, so I'm using my table. So I've got Na2CO3. I worked that out, that gave me 106. Then when I do my calculations, I like writing down what I've got. So I've got N, M and MR. My 1.166 has come from the question where I've highlighted. My 106 comes from my MR calculation, and then it's just a case of plugging those numbers in. So my mass is going to go into there, and my MR is going to go into there, and that's going to give me 0.011. Now question B, very tough question, getting towards those higher marks or higher tariff question. We're looking at hydrochloric acid here. Now we worked out the number of moles of Na2CO3, and we're now looking at 2HCl. What I want you to notice is that there is a big 2 in front of that. What that means is that for every mole of Na2CO3, there's twice as many as HCl. So I'm just going to times that number by 2. Now our last question here. Nice question. Circle the 3 errors. This is your ionic formulae. Okay, and I can show you some workings of how I did this in my head now. I've decided to do it this way. But I've given you a basic one down here, and that works for question 2. Okay, so just so you know where that is. So if I'm looking at magnesium bromide, I've got Mg and I've got Br. My charge of Mg is 2, and my charge of bromine is -1. Now, good little trick here. We're going to, for the number of each one, we're going to play crisscross. So I'm going to put 1 up there and 2 down there, and what that will give me is Mg Br2. So I've done that one there. So I know that was wrong because I've got Br1. Now we're going to carry on and do calcium oxide. So I could have calcium and oxide. I've got +2, -2. Again, play crisscross. I'm going to have 2 and 2. Now we could have CO2, O2. We've got a common number there, haven't we? Both numbers can divide by 2. So we'd have CaO. Finally then, for sodium iodide, easy mistake here, sodium symbol is Na. It's not K. Now this example here shows you it for Na2CO3. Now we'll just look again at barium sulfate, and I use that same method. So we're going to have +2, -2. Again, I've got that common number of an 2 and 2, so I could have Ba and I could make it really complicated for myself. I could get the brackets out, but the easiest thing to do is just divide it by 2. And it's going to give me BaSO4. Okay. Now, looks way more difficult. Then finally, one here, it's just a case of adding up how many atoms I've got. The difficult thing for you to look at here is that we have got a bracket involved, and these workings at the bottom are just me timesing the inside by 2. But make sure you leave that to 1, because the 2 doesn't point to that. Hopefully this has been helpful. So go back through, stop them wherever you need to. But I think that should help you answer that booklet. Okay, thank you very much.